Okay, welcome to PC Tech Episode 2. So if you watched PC Tech Episode 1, you know I really like the Haswell era Dell Optiplexes, so specifically Optiplex 7020, Optiplex 9020, the Optiplex XE2, and the Precision T1700, which is basically the same as these others. So they are cheap and capable and boring, and if you are essentially standardized on 4th gen Intel CPUs and DDR3 memory, these are a great source of motherboards and components that will help you keep your systems running pretty inexpensively. So thus far, I've actually built 3 systems using hardware from this generation of Dell machines. My home lab PC is an Optiplex 7020 motherboard in a standard ATX case. I use that for all of my home electronics work, video production, basically everything I do on my PC at home. That's my PC. I also built a PC for work based on a Precision T1700 motherboard in a standard ATX case. That's the machine I used all of the fall semester for remote teaching. We were doing basically in-person and remote teaching on campus, so that got me through lots of Zoom meetings and things like that. And I've also built a gaming PC for my son that has an Optiplex XE2 motherboard in it. This is just a great era of Dell hardware, and it's just wonderful for providing a really cheap way to keep your PC systems going. So if you watched my first video, or if you've watched any of the many Optiplex videos out there on YouTube, especially the ones by the Game Bench, you know that these systems have some quirks, proprietary connectors, non-standard components. It's not honestly a big deal because there are adapters that exist in many cases to help you adapt standard hardware to work with these motherboards. And also the components are just not that expensive. They were so heavily used in office PCs that have now been decommissioned. They're just really cheap on eBay. So personally, I don't find these quirks to be a big deal. So this video is just going to be a quick video where I show you what I do if I have a motherboard I need to test, or a CPU I need to test, or memory or other component. Basically, I built a test bench to help me set up a Optiplex system out of arbitrary components, including ones I want to test. And I'll show you how I put it together and how I use it. So just so we're clear, all the test bench is a frame that you can attach a motherboard, power supply, and other PC components to, so you can build a computer outside of a enclosed PC case. And what I noticed when I researched into buying a pre-made test bench is that they just seem really expensive for what they are. I didn't really want to spend $30, $40, $50 or more dollars for something that was literally just a frame that you could screw a motherboard onto. So I figured I can probably put something together that would work for a lot less money. Here is the Optiplex test bench that I built from scratch. The entire test bench was constructed using materials that I already had on hand, so in that sense I didn't really spend any money on it. If I had to purchase the parts new, it would probably cost about $25. The only truly essential feature of a test bench is a flat surface in which the motherboard can be mounted. I used a 14-inch by 11-inch sheet of acrylic that I reused from a different project. I mounted 632 hex standoffs in a standard micro ATX mounting hole pattern. The acrylic sheet is supported on one side by a Dell 290 watt power supply, part number HYV3H. I screwed the acrylic sheet directly to the top of the power supply using M3 bolts. I used some plastic spacers between the power supply and the acrylic sheet so that the overall height would match the 2x4 scrap I used for support on the other side. The entire arrangement isn't particularly elegant, but it does the job. I mounted a 2.5-inch to 3.5-inch hard drive adapter bracket on some 440 standoffs and used an old SSD to store the Linux Mint image I use for testing. At the front of the test bench, I mounted a small proto board on 2 standoffs. On the proto board, I wired a push-button switch to use as the power switch. I also wired 3 LEDs for the system power, diagnostic, and hard drive indicators. All of these components are wired to a dual-row right-angle pin header. This means I can use standard DuPont jumpers for the front panel connections to the motherboard. I find that it's quite useful to have a crimping tool for DuPont connectors when doing PC work, where you might need to make a custom jumper. The power switch, power LED, and diagnostic LED are connected to a Harbin repairs adapter which can plug into the proprietary 5-pin motherboard connector that the Dell motherboards use. The front of the test bench also has a front panel USB and audio assembly from an HP PC, which I bought on eBay for about $10, and which is connected to the acrylic sheet using zip ties. The assembly connects to another Harbin repairs adapter PCB, which plugs into Dell's proprietary 20-pin motherboard connector. This adapter also provides the connection for the hard drive activity LED. The Optiplex motherboards of this vintage require an internal temperature sensor, so I have one zip-tied to the front of the test bench. The part number for this sensor is N5G78. The motherboard will also require a case fan to be connected. The test bench has a case fan from an Optiplex 3020 small form factor PC mounted on two right-angle brackets using M3 bolts. The Optiplex systems of this era don't supply SATA power directly from the power supply, but instead use a cable assembly that plugs into the motherboard, which is Dell part number CR9TD. When I am testing a motherboard, I use a standard Dell CPU cooler, part number G8CNY. Alright, so just for fun, let me show you what I do when I am validating a motherboard. So here is an Optiplex XE2 motherboard. I've actually already tested this one, so I'm pretty sure it works. But I'll set it up on the test bench using a known good CPU and known good RAM, and we should be able to boot up and see if it works. Alright, everything's set up and connected, so let us power on, so hopefully we'll get a clean boot. Alright, OS seems to be loading. There we go. So here's our Linux image. Yeah, I think we can conclude that this motherboard works. I already had tested it and was pretty sure it worked. So anyway, that's what I do when I get a new motherboard, and if it passes this test, I'm pretty confident that it is going to work correctly when I install it in a different computer. Alright, so in conclusion, I don't think you need to spend money on a test bench. You can just make one yourself out of scraps, and it can be very serviceable. In general, I think that older office PCs are still very capable and a very good way to keep your PCs running or acquire new PCs. I found that these 4th gen Optiplex systems do everything that I need them to do. They are still 100% useful for the kinds of things that I do. So if you are going to be using older stuff in PCs that are important to you, I think it is really important to have a way to test components when you buy them to make sure that they work. The first motherboard I was going to use in this video actually turned out not to work, and the test bench helped me find that out so I could return it for a refund. Alright, so that's it for this video. Thanks a lot for watching. I might make another one of these PC Tech videos at some point, maybe, but we'll see. Alright, take care.